Okay, this is your Module 24 video. The first topic that we're going to start with is solving a system of linear and quadratic equations. Okay, so we've done systems of linear equations for sure. So now we're just going to make one of them be quadratic. So something like y equals x squared minus 5x plus 5. And y equals negative 2x plus 23. Okay, now these aren't a good candidate for your elimination method where we would add or subtract to cancel things out. Okay, these are going to be better where you set them equal to each other. So since they both equal y, we can do x squared minus 5x plus 5 equals negative 2x plus 23. Okay, and then what we want to do is get everything to one side. We want to get it to one side so that your x squared term is positive. So we're going to want to get everything to the left-hand side. So we're going to add 2x to both sides. And at the same time, we can subtract 23 from both sides. Okay, so that gives us x squared minus 3x plus 18 equals 0. Okay, and then that's a real nice, easy quadratic to solve. It is factorable. We could do x plus, wait, is it factorable? I was just thinking 9 and 2. Nope, that is not going to work. Let's see, 3 and 6 would work though. Yeah. Okay, so x, oops. So we can factor that to be x plus 6, x, what am I doing here? X minus 6. Wait, no. Okay. That should be 5 minus 23 is negative 18. Okay, so then we'd have minus 6 and plus 3. Sorry about that. Okay, so it's factorable. So then we can just plug it back, or solve for x is 6, or x is negative 3. Okay, so we get two answers there. We can plug them back in to get y using either of the equations. Use both to double check your answer. Just use one if you're pretty confident on your skills there. So y is negative 2 times 6 plus 23, which would be negative 12 plus 23, which is 11. So one solution will be 6, 11 for your xy pair. And then y equals negative 2 times negative 3 plus 23. So that would be 6 plus 23, which is 29. So your other solution is negative 3, negative 29. Okay. All right. Just make sure. Okay. Next problem. We have solving a system of nonlinear equations. Problem type 1. Okay, so this one we have x squared plus y squared equals 10. And we also have y plus x equals 4. Okay, so this is not as easy as just setting them equal to each other because they're not both solved for a variable. And it wouldn't really be that easy to solve the first one for a variable. Okay, so what we want to do instead is some sort of substitution where we can take the second one and solve it for one of the variables. So like y equals 4 minus x. Okay, we could just as easily do x is 4 minus y. It doesn't really matter, just as long as you get one of them. Okay, And then we can plug it in. So then x squared plus y squared equals 10. So x squared plus 4 minus x squared equals 10. Okay, so that's your trick to getting rid of one of the variables. So now carefully expand that. That'd be 16 minus 8x plus x squared. So then we'd have 2x squared minus 8x plus 16 equals 10. Okay, and then subtract the 10 from both sides. Okay. Now what we can do here is before we factor it, they're all even numbers, so we can divide by 2. Okay, and now we can factor. So we can do x minus 3, x minus 1 on that one. Okay, so x equals 3 or x equals 1. If x equals 3, y plus x is 4. So y would be 1. Okay, so then if x is 1, y plus x is 4, y plus 1 is 4, so y would be 3. So our two answers are 3, 1 or 1, 3. Okay. Our next one. We have solving a word problem involving geometry. Using a system of nonlinear equations. Okay, so for this one, we have the perimeter of a rectangle is 50.4 meters. Okay, and its diagonal length is 18 meters. Find the length and width. Okay, so let's draw a little picture here. We got a rectangle. Okay, there's your length, and there's your width, and then there's your diagonal, which we know is 18. Okay, so just make sure, look at each piece of information given to you separately. The perimeter is 50.4. So that means 2 times, I'm going to use capital L and capital W for length and width. 2L plus 2W equals 50.4. Okay. You could also split that in half. Okay. Length plus width should equal 25.2 then. Half the perimeter, right? Okay. It's diagonal. So that's your Pythagorean theorem there. L squared plus W squared equals 18 squared. Okay. So then it's basically like the problem that we just did up here, right? We had x squared plus y squared equals 10. Now we have L squared plus W squared equals 18 squared. And we also have the sum. Okay. So we can just go ahead and make this be L equals 25.2 minus W. Okay, so that 25.2 minus W squared plus W squared equals 18 squared. Okay, and so we can expand everything out. This will be 635.04 minus 50.4 W plus w squared equals 324. Okay, so 2w squared minus 50.4w plus 635.04 equals 324. And then we can subtract the 324 from both sides. Okay, we probably don't want to factor that. We don't have to deal with factoring decimals. We can use your Pythagorean theorem. So w is the, here, let's remember, x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're solving for w as our variable instead of x, okay? So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, that works out to be 50.4 plus or minus, we're going to have the square root of 51.84 over 4, which is 50.4 plus or minus 7.2 over 4. So we get that w is 14.4 or 10.8. Okay, and that happens to be your length and your width. Okay, so your length would actually be the longer one, and then your width would technically be the shorter one. Okay, so it's nice. You actually, when you use the Pythagorean theorem like that, you get, or not, when you use a quadratic theorem like that, you get both the answers that you need. Okay. All right, moving on. The next one, we have a graphing one. Let me get my graph background on here. We have graphing a linear inequality in the plane, vertical or horizontal line. Okay, so for this one, we're going to have something like x is less than -3. Okay, you're used to graphing that on a number line. We would have our number line, -3. Okay, you'd have x is less than -3, so you'd have an open circle, and you would shade to the left. Okay. Now we're doing it in the plane. So we want your xy plane for this one. Okay, so you first of all think about the line x equals -3. Okay, that is a vertical line. Regardless of what y is, x is just always -3. Okay, so this is where that line would be. All right. Now, the thing is that the less than symbol, if you might remember, that's a dashed line. If we have less than or greater than, it's like having an open circle. Okay, if we have this, we would do a solid line. It's like having a filled in circle. Okay, so what we actually want to do here is have a dashed line at x equals -3. Okay, and then just like on a number line, we shade to the left. We still want the values to the left there. Okay, it's a half plane there that we shade in. So any point in there has an x value of less than -3. Okay, we could do another one with a y. I think they're going to give you some y ones, yeah. If, for example, we had another one where y was less than or equal to 6. So we would, on your plane, find y equals 6, which is horizontal. And since we have less than or equal to, we're going to do a solid line. Okay, so at y equals 6, let's say it's there, a horizontal line. And then it's all the y's that are less than that, so below that line, so we would shade below it. Okay. All right, next one. And I know you guys did these in algebra too also, because I remember teaching these. We have graphing a linear inequality in the plane, slope-intercept form. Okay, so same thing. We're just going to graph a line. We're going to use the same rules where if it's less than or equal to, it's a solid line, or greater than or equal to a solid line. If it's just less than or just greater than, it's a dashed line. Okay, we're going to have y is greater than or equal to negative 3x minus 2. Okay, so again, the first step is to graph your line. So your y-intercept of negative 2. Okay, and then your slope of negative 3. So down 3 over 1, up 3 left 1. Okay, and we're going to do a solid line because it's less than or equal to. Okay, so we're going to do like this. All right, and then the way this one is set up, it has y is greater than, so we can shade above that line. Okay, since it's greater than or equal to, that means we shade above. So just like that. Okay, if it was less than, we'd shade below. All right, next one. We have graphing a linear equality in the plane standard form. Okay, so in this one, your equation will be in a standard form of a line. So standard form, remember, is ax plus by equals c. Okay, so we have negative x plus 3y is greater than 12. All right, so remember when you graph that, you find your two intercepts. So if we, first of all, we just think about the line negative x plus 3y equals 12. Okay, if x is 0, then 3y is 12, and y is 4. If y is 0, then negative x is 12, and x is negative 12. Okay, so we're going to graph that line, and we're going to make it dashed because of the symbol there. Okay, so we graph when x is 0, y is 4. When y is 0, x is negative 12. And we're going to connect with a dashed line. Okay, now you can't use the same rule of where to shade as we did in the previous one because it's not solved for y. So one option would be that you could solve it for y. Okay, the other easier option is to just test the point 0, 0. If 0, 0 makes the statement true, then we should shade where 0, 0 is. If 0, 0 does not make the statement true, then we should not shade where 0, 0 is. Okay, so negative 0 plus 3 times 0, is that greater than 12? Okay, so in other words, is 0 greater than 12? And the answer is no. So don't shade 0, 0. Okay, so when choosing which half to shade, we're going to shade the half without 0, 0. Okay, so that's going to be our answer there. All right, our next one is graphing a quadratic inequality and this is problem type 1. Okay, so we're going to graph y is greater than negative x squared minus 6. Okay, and it's the same thing as when you do the one for a line. Okay, we just want to graph y equals negative x squared minus 6 with a dashed line. Okay, and then we're going to shade above it. Okay, so that's all we need to do. When you graph your parabola, if you want, you can come up with a table of values. I can tell this is going to be y equals x squared. It's going to be flipped and moved down 6. Okay, so at 0, negative 6, we have our vertex, and we're going to do our dashed line. Okay, and we could get more numbers in there. Like if I plug in 1, then I'll have y is negative 7. Negative 1 would be negative 7. Okay, you could keep moving your way out from there. Okay, and then again, since this y is greater than, we're going to shade above. So above the parabola there. Okay, all right, our next one. We have graphing an inequality involving a circle. So that's kind of fun. Okay, basically you're going to graph your circle and either shade inside or outside. Okay, so x squared plus y plus 4 squared is greater than or equal to 25. Okay, so we're going to graph the circle with a solid line because of the greater than or equal to. Okay, we want all the xy values that are greater than the radius squared when we use this equation. So we would graph outside, or sorry, shade outside. Okay, we want the x and y's that are outside of that radius. Okay, so your circle has a center at 0, negative 4, and a radius of 5. Okay, so we're going to graph 0, negative 4, the radius of 5. Okay, and then a solid line, or solid border, I guess. Ooh, it's a little bit more ovalish than I wanted. Okay, and then we're going to shade outside of the circle. Just like that. Okay, and again, if it had been greater than, rather than greater than or equal to, we would have used a dashed line. If it would have been less than, we would shade inside. Okay. All right. Oops, almost lost my spot there. Hold on. Okay, we want graphing. Excuse me. Graphing a system of two linear inequalities. Basic. Okay, so now we're going to have two that we graph. Okay, and if you remember that from Algebra 2, you figure out where you would shade, and then you only include the shading that is included on both of them. Okay, so we're going to have y is greater than or equal to 4x plus 3. So this goes back to one of the first topics here in the module. Y is less than negative 3x minus 8. So We're going to graph our two lines. So the first one, a y-intercept of 3 and a slope of 4. And it would be solid. Okay. And I would graph above that one, or shade above it. Here, I'm going to use a highlighter to shade. So we did this one. Okay. And then for our second one, I'll do red for that one. Okay, we're going to have the y-intercept of -8 and a slope of -3. Okay, so that line would be like that. Ooh, and it would be dashed, so I gotta fix that. Okay. And I would shade below that one. Okay. So I just want to see how Alex wants you to do your final answer here. Just a second. Okay, it looks like they just let you. Your final answer then on Alex. I believe what you're going to do is you're going to graph the first line. So you're solid. Ooh, that's a little crooked. Okay. Then you're going to graph your second line. Okay. And then you're going to do your shading. Choose which of the, you really have 4 choices of where you want to shade, right? Where it makes the X, it makes 4 regions. So we want to shade this region here. Wherever the overlap is your region, okay? That's where both of those equations are satisfied, where y is greater than 4x plus 3, but less than -3x minus 8. I should say greater than or equal to 4x plus 3, but less than -3x minus 8, okay? All right. Next one. We have graphing a system of 2 linear inequalities again. Advanced. Okay, and what makes this one advanced is that they give them both in standard form for you. Okay, so I'm going to switch different colors right away. So we're going to have one in red. So 5x plus 6y is less than 6. And then we're going to have the other one be -4x plus 5y is greater than or equal to 15. Okay, so we're going to have a dashed line for the first one. Okay, if x is 0, then 6y is 6 and y is 1. If y is 0, then 5x is 6 and x is 6/5. So there's our 2 points that we're going to plot. 0, 1, and 6/5, 0. Okay. Let me get it going over here. Okay, so 0, 1, and 6/5, 0, and a dashed line there. Okay, and then we can test our 0, 0. So is 5 times 0 plus 6 times 0 less than 6? Is 0 less than 6? No. So we don't shade 0, 0. Okay, so we would shade that part. Okay, so don't shade 0, 0 on that guy. Okay, and then for our second one, we would use a solid line. Okay. Oh, did I just mess that up? Hold on. Oh my goodness. Okay, I'm going to blame it on being sick. Okay, 0 is less than 6. So we do shade 0, 0. Oh my gosh, I can't believe it. 0 is less than 6. Yes, so shade 0, 0. So we would shade below it there. Okay. All right, solid. If x is 0, 5y equals 15. So y is 3. And then if y is 0, negative 4x equals 15. So x is negative 15 fourths. Okay, so we're going to have our points 0, 3, and negative 15 fourths, 0. Okay, so 0, 3, negative 15 fourths is almost negative 4. Okay, and we're going to do a solid line there. Okay, we would shade there for the red too. Okay. Test your 0, 0. So negative 4 times 0 plus 5 times 0 greater than or equal to 15. Is 0 greater than or equal to 15? That is a no. So we don't shade 0, 0. So on the blue line, we would shade above it. Okay, so you can see where we need to shade for our system would be right in here. Okay, because we would shade below the red line and above the blue line. So this purple is where it would overlap. Okay. All right, next one. We have graphing a system of 3 linear inequalities. Okay, so we want the overlap now of 3. Okay, so it just adds one more layer to what we've been doing. Okay, so for this one, we'd have something like negative 2x plus 3y is less than or equal to 12. Oh, and they give you some pretty easy ones. X is greater than negative 5. Y is less than or equal to 7. Okay, so nothing too terrible here. Just do them each separately, and then we look for where all 3 overlap. Okay, so for our first guy there, we would do a solid line. Okay, if x is 0, then 3y is 12, so y is 4. If y is 0, then negative 2x equals 12, so x is negative 6. Okay, so we would have negative 6, 0, and we'd have 0, 4. And we would connect those with a solid line. And we would shade check 0, 0. So negative 2 times 0 plus 3 times 0 is less than or equal to 12. 0 is less than or equal to 12. That's true. So we would shade below it. Okay, so we would shade below. I better check, make sure I'm not making any silly mistakes again. Okay. Then for our x is greater than negative 5, we would get your horizontal line. I'm sorry, your vertical line. At x is negative 5. Okay, and we would do dashed. Like that. Okay, and x is greater than, so we would shade to the right. All the x's that are bigger than that. Okay. And then finally, let's maybe use green. Y is greater than -7, so that would be a horizontal line. Solid. And we would shade below. So 1, 2, 3, 4, 5, 6. Oops, I'm kind of off the chart here. Way up here. Okay. And I would shade below it. Okay. So where they all overlap, I'm going to get a... is right in here. This is where they overlap. Almost looks like an Easter egg. Okay, so I can redraw this nicely. I think on Alex it's actually going to not be as busy for you. Okay, but I would do my orange line, the solid, my purple line, that's the dashed, and my green line, that's also solid. Okay, and then I would shade. Just like that. That would be my final answer once I take my time and figure out where all the shading overlaps. Okay. All right. Next one. We have graphing a system of nonlinear inequalities. Problem type 1. Okay, so for this one, we'd have x plus y is greater than -1, and y plus x squared is less than 0. Okay, so the first one, you should be okay with graphing that. It's your line in standard form. Okay, we would again, it would be dashed. If x is 0, y is -1. If y is 0, x is -1. So we can do 0, -1, and -1, 0 with a dashed line. Okay, and then we would check 0, 0. So 0 plus 0 greater than -1. 0 is greater than -1. So I would graph the half plane that contains 0, 0. Okay, so that's where I would shade. All right. Now for the parabola, it's a little bit trickier. We're not used to graphing parabolas that look like that. Okay, so I can just do y plus x squared equals 0. Okay, so then y equals -x squared. Solve it for y like that. All right, so I'm going to graph a parabola, and the only transformation is that it opens down. Okay, and I am going to use a dashed line because of the less than, not less than or equal to. Okay, so here I would graph like this. Okay, and I could get some points on there. I could get the point 0, 0, 1, -1, -1, -1, 2, -4, -2, -4. Okay. And then to figure out where to shade, again, I can just test a point. I don't want to test 0, 0 because that's on the boundary. All right, so that's the one thing where with the lines too, we've always been successful here checking 0, 0, but if 0, 0 is actually on the boundary, you can't check it. So just check any point you want. So like I could check the point 1, 1. Okay, so going back to my original, 1 plus 1 squared less than 0. So 2 less than 0, it's not. Okay, so I would not shade the piece that contains 1, 1 for my parabola. Okay, so I would shade below the parabola. Okay. So now my final answer, again, as always, is just where it overlaps. So my final answer, I would have the line. I would have the parabola. And the shading would be in between the two. Okay. All right, I think we only have one more left. Okay, this is solving a word problem using a system of linear inequalities, problem type 1. Okay. All right, so let me grab a drink of water quick before I read all this. Okay, so Susan, we have Susan will donate up to $480 to charity. Okay, so there's a good hint there, up to. So whatever she donates has to be less than or equal to 480. Okay. The money will be divided between two charities. So she's got the City Youth Fund and the Educational Growth Foundation. Okay. Susan would like the amount donated to the Educational Growth Foundation to be at least 4 times the amount donated to the City Youth Fund. Okay. So she wants that to be at least 4 times. At least 4 times what she donates to the City Youth Fund. Okay. So if we'll call the City Youth Fund C, and we'll call the Educational Growth Fund E. Okay. So she wants her donations to E to be at least 4 times C. Okay. So think about it. And I always like to think about numbers and make sure that what I wrote makes sense. So like if she donates $100 to the City Youth Fund, okay, then she wants to donate at least $400 to the Educational Growth Foundation. Okay. So the way that that set up is right. Okay. And then also, go back to that, E plus C is at most 480. Okay. Let's see. They say let X equal the amount donated to the City Youth Fund. Okay, so they decided, they tell you they want this to be X. Okay. And Y be the amount to the Educational Growth Fund. So she wants, this will be Y, not E. I guess it makes sense since we have to graph it. Okay. Shade the region corresponding to all values of X and Y that satisfy these requirements. Okay. So now it's just graphing your inequalities. Okay. So the first one, Y is greater than or equal to 4X. Okay, so we would graph Y equals 4X with a solid line. And since Y is greater than, we would shade above. Okay, so Y equals 4X. Go through the origin. Okay, and then we would shade above it. Okay, and then for our second one, we would have Y plus X is less than or equal to 480. Okay, so for this one, we can graph when x is 0, when x is 0, y is 480. When y is 0, x is 480. Okay, we'll use a solid line. So 0, let's say that this is 480. Say this is 480, 0. Solid line. And now we're going to figure out if we shade 0, 0 or not. Okay, so 0 plus 0 less than 480? It is. So we'll shade 0, 0. So we would shade here. Okay, so we can see that overlap there. One thing, too, that makes this one tricky is the fact that she's not going to donate negative money. Okay, so that would be ridiculous because then you're taking money away from a charity. And that's definitely not something she would want to do. Okay, so we can add in this and only shade to the right there too. So your overlap would be right in there. Okay, I think Alex will probably take it without that. But just in case, with these word problems, a lot of times it doesn't make sense to have negative values. Okay, so what we would have for our final answer on this one would be this right there on Alex. Okay. All right, I think we got an example of each problem. So there you go. Let me know if you need help with anything.